for the first problem, they tell us that there's a lead shot and it weighs 343.6 grams. So write that down. When you're taking a reading problem, what you want to do is you want to pull out the information from the reading problem, organize it, and then come up with that plan of action. All right? So another thing that's helpful on this problem is if you draw a picture. So it doesn't have to be anything fancy, but here's like a graduated cylinder, and here's this alcohol in it, and the density of the alcohol that's in here, density equals mass divided by volume, and make sure you understand that equation. But the density of this alcohol is equal to 0.785 grams per cubic centimeter. Or here's something to remember. 1 cubic centimeter is equivalent to 1 milliliter. Again, if you're in nursing, 1 cubic centimeter, that's what we call 1 cc. All right. So you could also say the density of alcohol is equal to 0.785 grams per milliliter. All right. So what happens is you place this lead shot or slug into the alcohol, and that's going to cause the volume to rise somewhere up here. So we have this change in volume, and they tell us that the change in volume is 30.3 milliliters. That's what this change in volume is. All right. So what this change in volume represents is how much of the alcohol was displaced by the volume of the lead shot here. All right. So we can figure out what the volume of the lead shot is. It's 30.3 milliliters. That's how much the volume changed here. So in order to determine density, we have to know the mass of the object, which is 343.6 grams, divided by the volume change of the object, which was 30.3 milliliters. All right. So the density is equal to 343.6 divided by 30.3. That equals 11.33 grams per milliliter, or that could be 11.33 grams per cubic centimeter. If we're talking about solids, we usually use this, grams per cubic centimeter. If we're talking about liquids, we usually use grams per milliliter. Now, let's watch here's another important thing. Let's watch our significant figures here. Our significant figures, this value is 30.3. That's 3 significant figures. And 343.6 is 4 significant figures. So when you divide something with 4 by 3 significant figures, the lowest is what you report as your final answer. So we look at the 1, 2, 3 significant figures, look at the number adjacent to our least precise part of the measurement, the tenths place there, and it's less than 5, so my final answer would be 11.3 grams per cubic centimeter. All right? So that's the answer for the first problem. The second problem says that you need 1,200 milligrams of calcium per day, and that's also called RDA. All right, and they tell us that the way we're going to get this calcium is through calcium carbonate, and calcium carbonate is 12% calcium. And we need to get 1,200 milligrams of calcium here. So here's the tricky part of this question. When somebody says a percentage, what that means is it's 12 out of 100. All right. So what they said, it was 12% calcium. So that means 12 grams of calcium out of 100 grams of calcium carbonate. All right. And the question is, how much calcium carbonate would you have to swallow to get 1,200 milligrams of calcium? How many grams of calcium carbonate would you have to swallow? This is limestone. This is generally what people get this from is oyster shells or something like that. But limestone could be used as well. Chalk. So how many grams of calcium carbonate do you have to swallow to get 1,200 milligrams of calcium? All right. So let me just say this. Generally, when you see something like this, a complex unit, something over something, that's not what you want to start with on your problem. What you want to start with is an individual unit like 1,200 milligrams. So what we're going to do here, we're going to take our 1,200 milligrams of calcium. We're going to convert that to grams of calcium. Once we convert that to grams, we will use this 12 grams per 100 grams of calcium carbonate to determine grams of calcium carbonate. And then depending on what that answer looks like, we may change it to milligrams of calcium carbonate. But there's our plan of action. So we have two conversion factors. In order to convert milligrams to grams, you must know this. You should memorize this, that 1 milligram is equal to 10 to the negative third grams. Milli means 10 to the negative third. All right, so we're going to use that as a conversion factor. We're going to take the 1,200 milligrams, what we were given, multiplication symbol, quotient bar. We need to get rid of the milligrams. We need to end up with grams. So up here we need to divide both sides of our equality by 1 milligram. This side becomes 1. That tells me this is a true conversion factor. So I'm going to say 10 to the negative 3 grams over 1 milligram here. All right. The milligrams will cancel out. We'll be left with grams of calcium. And so let me put calciums here just to keep this in line. So the next thing we need to do is we need to convert this from grams of calcium to grams of calcium carbonate. Well, where's that relationship? It's up here where they said that calcium carbonate is 12% calcium, and here's our relationship. So we're going to put the 12 grams of calcium in the denominator and the 100 grams of calcium carbonate in the numerator. So what's going to happen here is the grams of calcium are going to cancel out, and we're going to be left with grams of calcium carbonate. So when we calculate this out, we'll now know how much calcium carbonate we have to ingest, knowing that it's 12% by weight calcium, to get our daily allowance of 1,200 milligrams. All right. So on your calculator, what you're going to do is take 1,200. You're going to multiply that by 1 exponential negative 3. You're going to divide by 12, and you're going to multiply by 100. And hit enter, and we get 10 grams. 10 grams of calcium carbonate. All right. This has two significant figures. Remember, those zeros are placeholders. This has 2. We should put a decimal there to represent that that has 2. So either, yeah, that's probably the best answer. 10 with the decimal grams of calcium carbonate. I hope this helps. This is the type of conversions that you'll be doing throughout Chemistry 140. I'm not so interested in the answer, although you have to do that for the test and the quizzes. What I'm interested in is you're taking the reading problem and breaking it down into steps. If you can do this, you'll be able to handle any type of mathematical problem in Chem 140. But it is tough if you've never done conversion factors before or conversion problems. The best way to get proficient at this is doing lots of problems. That's why I assign all those odd problems in the back of the chapter. I know some of it seems repetitive, but through doing multiple problems, you'll start thinking in a logical manner how to take a reading problem, break it down into its components, and then build it to whatever answer you're seeking. I hope this helps, and hopefully we'll hear more from you. Like I said, I'll be glad to help you as we go along here. I'm just a guide, though. You really do have to put in the effort yourself in order to get this to work. Thank you.